So now I want to introduce my teammates. So the first teammate are Nur Hakim Arif bin Muhammad Rasali. The matrix number is CE240049. The second person is Kesawa Amalaki Shiogo. His matrix number is CE240223. And the third person is me, Kesrafadi Amalaki Bala, CE240226. And the last person is Sunesh Prasant Analaki Mahindran, and his metric number is CE240234. So, my name is Putrapati Son of Power, and I'm here to present the question 1. So, let's look up the questions. For x squared plus y cubed equals to 4, to each of the following. A. Find the y prime by solving the equation for y and differentiation directly. B. Find the y prime by implicit differentiation. C. Check the derivative if A and B are the same. So let's look at the manual calculation. So now we are in manual calculation for the question 1. So first we will find A and B, then go to C. So the first A question, I was firstly use the formula y cube equals to 4 minus x squared, and the cube to convert to the right hand side becomes square root 3, and then we need to differentiate the fourth equation. So the y prime equals to 4 minus x squared power of 1 over 3, because 1 over 3 equals to square root of a 3. Then after the differential, the final answer we are get is minus 2x over 3 open bracket 4 minus x squared close bracket power 2 over 3. Then we go to the question B. Find the p prime by the implicit differential. So we take the question equation, then we need to differentiate each question by their constant. So the answer we are get after the is 2x plus 3y squared equals to 0. Then we need to divide the x. So the additional value we should to convert to right hand side. So the 2x become negative 2x, and the plus 3y squared become over 3y squared. So the final answer dx is dy dx equals to 2 minus 2x over 3y squared. So let's go to the question C. The question C are check that differential in A and B are same. So we take the both answer gathered by A and B, and we put in the same equation. So they will be minus 2x over 3y squared equals to minus 2x over 3 bracket 4 minus x squared 2 over 3. So basically y cube equals to 4 minus x squared. So that means y equals to 4x minus 2 square close bracket power 1 over 3. So we just convert the word into our B part answer. So they look like a similar, because when y cube is 4 minus x squared, then the y squared becomes 4 minus x squared 1 over 3 times 2. So the answer will be 4 minus x squared power 2 over 3. So it's look like the same. So the answer yes. The derivatives of A and B are exactly same. So let's we go to the software solution. For this solution, I was using MATLAB version 2024A, and also I was proven the whole coding that I was using to solve this question in MATLAB. So in the coding, you can see I was inside every each and questions coding, and I was giving the reference to handle. header file and the green line. So you can see the question A's coding, question B coding, and the question C. And the right hand side, you are looking at the answers for the question A, B, and C. So the answer are very similar to the manual calculation. So I would like say maybe the answer should be correct. And this is the software video that I really prove that the coding was run and they will get the exact value of my manual calculation. So well guys, we are continuing to the question 2. So let's we see the question. For x over y cubed equals to what? Do each of the following. A. Assume find the y prime by solving the equation for y differentiation directly and find y prime by the implicit differentiation and check the derivative A and B are the same. So well, we are going to the manual calculation of question 2. So we starting from the question A, find the y prime by using the solving equation by y differential directly. So of course, we need to convert the x to right hand side and we still constant the y in the left hand side. So after we convert, the equation will be y cubed equals to x. So we convert the y cubed to the right hand side, it will become y equals to x power 1 over 3. And we need to differentiate the y. So the answer should be that is y prime equals to 1 over 3x power of 2 over 3. And we go to the question B, that will find the dy prime by using implicit differential. So we need to differentiate x and y in the same time. So we does not use the similar method. So we use chain rule. So the chain rule equation is v dot u prime minus u times v prime over v squared. So after we convert and input all answers, the y equation, I mean y prime will be y power 3 minus 3y power 2 times x over y 6. So we need to simplify and we just need the y answer. So after simplify everything, the answer we are getting is y prime equals to y over 3x. And the simplified method I proven in the manual calculation. If you want to need more explanation, you can see zoom and check each and everything. So let's move to the question C. The question C is check the expression A and B. As usual, we need the same method. We need to take A answers and B answers in equation. Then we need to check the both should be the same answer. So y1 equals to x, I mean y prime equals to x power 1 over 3 over 3x. So the another answer that we get is 1 over 3x over 2 over 3. So they should be more similar and the answer will be the same. So yes, A and B derivation are exactly same. So as I mentioned before that, for the manual question 2, I proven the question in math lab and the coding I show in my slide. These are the coding I was input for finding the answer for question 2. And I was mentioned here in the coding which coding are for the question A, question B, and also C. So the right hand side, they have the answer that given by the MATLAB for question A, B, and also C. So when looking at questions, when looking at answers, they are most similar like my manual answer. So this way are proven that my manual answer and also software should be correct and same. So this is the video that I run and take screenshot that is the coding was run and get the correct answer that's shown by my manual calculation. So well, we continue the question 3 and as I know this question 3 is more suspense and very interesting and bit complicated because they are giving a lot of equation to find every each answer. So let's go to the question. Given the following information, use the chain rule to determine the delta W over delta T and delta W over delta S. So the given the sub equation W equals to square root x cube, that is x squared plus y squared plus 6z over y, and the x should be equal to c p, and y equals to p plus 3t minus 4s, and the z equals to t cube over s squared, and the p equals to 1 minus 2t. To do this, we'll need to solve in the tree diagram. So they are given a lot of equations. So we need to find each and every differential constant words. So let's show by the manual calculation. So as I mentioned that question 3 look more difficult and complicated. So the solution method should be longer than the previous questions. So let's check the manual calculation. So the first we need to uh, identify the every equation that given W equation x, y, z, and p. Then we need to set of question to find each and every differential. Example, uh, dx over dt equals to cos p, and differentiate of dp over dt equals to minus 2, dy over dt is 3, and dy of ds minus 4. These every answers are given by taken from the equation, and we are writing to the left hand side table. Then we should take a partial derivative that dw over dx equals to x squared plus y squared over 1 over 2, and 1 over 2 will differentiate come in front, and x squared plus y squared in bracket, and the power will be minus 1 over 2, and we need to differentiate the integral part of x, so they will get 2x. So the final answer of differentiate dw of dx is x over square root x squared plus y squared. Then we need to differentiate the dw of dy. So the equation is x squared plus y squared close bracket power of 1 over 2 plus 6z times y power of negative 1. So after we differentiate the y, the final answer we get is y over x squared plus y squared under square root plus 6z over y squared. So the last we need to find is differentiate w under z. So as seen, take the same equation of square root x squared plus y squared in square root plus 6z over y. So of course, there's only have the z under the behind one, so the final answer should be 6 over y. So let's move to the find the delta w and delta t. For delta w over delta t, there is a huge big equation that's proven in the diagram. So we just convert the values we find out in previous paper, and they get everything delta w over delta x over delta p times delta p over delta t, delta w over delta y over delta t, delta w over delta z over delta t. So after converting everything, the final answer should be minus 2x cos p over square root x squared plus y squared plus y over x squared plus y squared minus xz over y cubed close bracket plus 18t squared over ys squared. And for the d delta w over delta s, this have a big formula too. So after converting every value that we get it, so the final answer should be minus 4 open bracket y over square root x squared plus y squared minus 6 over y squared close bracket plus open bracket minus 12 t cubed over y s cubed close bracket. So it should be a long answer, and let's recheck our answer by using software. So the software part. So as I mentioned, I was using the method to solve the question. So I was finding the coding inside the coding the method, and in the method we can identify every each step why I was using this code, because I was mentioned at the side of the coding that why I was inside this coding, why I insert these values. Then the right hand side you can see the final answer that given by the coding. So it's look 99.9% similar to the manual calculation. So I hope this answer also should be correct. And this is software video of question 3 that I was run in MATLAB, that I proved the coding as run and get the same answer by the manual calculation. And this is software video of question 3 that I was run. So hello guys, now we are in question 4. This question 4 is literally difficult and it was under volume subject. So let's check the question. Calculate the volume under the surface z equals to 3 plus x squared minus 2y over the region D is defined by 0 lesser than x lesser than 1 and the negative x lesser than y lesser than x. So they are giving the information about z equation, and also they are giving how the x value should be. So maybe it's easy to find the answer. So let's we check it out in the manual calculation. So in manual calculation, we use double integral method. So we convert the values that we get in by the question to double integral form, that is integral 1 0 and the integral x minus x and bracket 3x plus x square minus y square dy dx. So for the double integral, we need to take dy and the second integral. So after the integral, the answer we are getting for the get is x 6x plus yx cubed. And the double integral form should be a little complicated. So it when I was explained, it should be longer the video. So I was reduced. If you need more, you can zoom it out and check each and every part that I was showing very clearly. Then we go to the second integral. For the second integral, we need to do dx by using first integral. So integral 1 over 0 and integrate the 6x plus 2x cubed and differentiate, I mean, integral the x part. So after integral the x part, the final answer that we get is 1 over 2. And 3. So after the adding everything, because we differentiate two part, one is 6x, another thing is 2x cubed. So for the integral the 6x, we get 3, and integral the 2x cubed, we get 1 over 2. So we add both answer, then the final answer we get is 7 over 2. So now we are in the software solution, because software solution is important for this part, because software solution is one of the proven method to check our manual calculation is correct or not. And the previous calculation or questions we are using longer coding for get answer. But this one, as I mentioned, this is a volume, and the main process is double integral. So we no need to put a lot of coding to find this answer. So the coding was so lesser, and yeah, straight away I was inside the question. So the answer was given by the right hand side. That's 702. So the manual calculation answer also 702. It should be 100% correct, and it should be right, and it was a proven theory. And this part just run the coding and proven that the coding was run very successfully and prove the similar answer from the manual calculation. So that's it.
Hello, my name is Keshwar son of Selvu. My matrix number is CE240223. Today I would like to present about my multivariable calculus group project, which is I would like to present question 5, 7 and 8. So first of all, I would like to present question 5, which is calculate the volume between the surface z equals to fxy equals to 3 minus x square minus y square, and the surface is z equals to gxy equals to 2x square plus 2y square. To solve this question, step 1 is understand the surface, which is the top surface is z equals to fxy equals to 3 minus x square minus y square, and the bottom surface, which is z equals to gxy equals to 2x square plus y square. So we want to calculate the volume between these two surfaces. Next, we want to find the region of the integration. To find the region where the two surfaces intersect, we equate them, which is 3 minus x square minus y square. It will be 2x square plus y square. To solve this equation, we will get x square plus y square equals to 1. Next, which is set up the double integral. We subtract the bottom surface from the top surface, which is volume equals to integral of R, which is region, 3 minus x square minus y square. So it will be minus with second surface. So 2x square plus y square, it will be dA. To simplify this expression, we will get double integral R 3 minus 3x square minus 2y square dA. Next, we would like to convert the polar coordinates. Since the region is a circle, we use polar coordinates. So x will be r cos theta, y will be r sin theta, and dA will be r dr d theta. So the integral will become integrate 2 pi 0, and second integral 1 over 0. So in bracket 3 minus 3 r square, we will multiply with r dr d theta. So we will get 3r minus 3r. So it will become 3r power of 3 dr d theta. So in the integral, we will get in the bracket, which is 3 over 2 r square minus 3 over 4 r power of 4 d theta. So we continue, which is the integral 2 pi 0 in bracket 3 over 2 minus 3 over 4 d theta, and we will get 2 pi 0 3 over 4 d theta. So after we solve it, the final answer we will get, which is 3 pi over 2. So this is a software solution which I use MATLAB software to verify the answer is correct with my manual calculation. So it's correct. I have verified the answer, which is the final answer I get for question 5 is volume equals to 3 pi over 2. And this one is my software simulation video, which I provide slide before this, which is like then a screenshot. I have provided the answer. So this is the simulation video that I have start from the beginning to the end. So for the question number 7, which the question is evaluate the triple integral y cos z power of 5 dx dy dz. Now I would like to explain the manual calculation for the question 7, which is evaluate the y cos z power 5 dx dy dz, which is a triple integral problem. So now we have to evaluate the innermost integral with respect to the z. Since there is a no x in the integrals, so the integral becomes 3y cos z power of y dy dz. So next, substitute into the double integral. So first integral 1 0, second integral z square 0, 3y cos z power of 5 dy dz. So it will become 3 over 2 z power of 4 cos in bracket z power of 5 dz. To solve this, we must use substitution. So u equals to z power 5, we will get, it will become du over dz equals to 5 z power of 4 dz. So it will become z power of 4 dz equals to 1 over 5 du. So next we substitute into the integral 3 over 2 integrate cos z power of 5 we times with z power of 4 dz. So it will become 3 over 2 integral cos u we times with 1 over 5 du. Next for the next time is we will get 3 over 10 integral cos u du, and 3 over 10 1 integral 1 0 cos u du. So to solve the final integral 3 over 10 integral 1 0 cos u du, so it will become 3 over 10 sine u 1 over 0. So next 3 over 10 sine 1 minus sine 0. So lastly we will get the final answer, which is 3 over 10 sine bracket 1. So the value of the triple integral is 3 over 10 sine 1. So this is the software solution for the question 7, which I verify the answer for manual calculation using MATLAB software. So I get the same answer for the manual calculation. So the final value of the triple integral is 3 over 10 sine 1. So this is the software simulation video that I do for the question 7 to get the answer 3 sine 1 over 10 for verify. The answer is same with my manual calculation. So for the question number 8, the question is evaluate integral 6z square where E is the region below 4x plus y plus 2z equals to 10 in the first octant. So I would like to present my last question of my part, which is question number 8. We are given a triple integral to evaluate E 6z square dv, where E is the region below the plane x plus y plus 2z equals to 10. And we are working in the first octant. So to simplify the calculation, we have to switch the polar coordinates in the xy plane. So we are now evaluating. So to integral our region x squared plus y squared dA. Since x squared plus y squared equals to r squared, this become 2 integral r region r squared times with r dr d theta. So it will become r power of 3 dr d theta. Next, we have to integrate with respect to the r. So first integrate 1 0 r power of 3 dr, so it will be get r power of 4 over 4 10 equals to 1 over 4. So now we integrate with respect to the theta, which is the first integrate 2x0 1 over 4 d theta, so it will become 1 over 4 times with integral 2x0 2 theta. So it will become 1 over 4 times 2 theta. So the final answer for the integrate with respect to the theta is pi over 2. So the final answer is pi over 2. So see, this is the software solution for question 8. So for this software solution, I have used MATLAB to verify the answer that I get from my manual calculation is correct, and uh, it's similar with the software solution. Okay, for this slide, which is the software simulation video that I have to for question 8 to get the answer to or to verify the answer for similar to the manual calculation that I have done.
And good evening to everyone. So my name is Nur Hakim Arif bin Muhammad Azali. My matrix number is CE240049. So I will present to you my first question, question 9. So sketch the vector field for fxy equals to xi minus 2j. So in this xy equals to 2x minus 2. So we sketch a constant vector field fxy equals to 2i minus 2j. This means every vector or arrow in this field point is in the same direction, to the right and downward. So question 9, our MATLAB we use the quiver function to draw the field over a grid from -4 to 4. So here is u equals to 2, v equals to -2 at very point. So all arrows have the same direction and length. We will proceed to question 10. So as we can see, we calculate the gradient of the function fxy equals to y power of 2 cos 2x minus y. So we can get here the gradient vector. Gradient vector is delta f xy equals to partial derivative f over partial derivative x and partial derivative f over partial derivative y, and we can get the answer. So the gradient vector field for fxy y power of 2 cos 2x minus y is minus 2y power of 2 sin 2x minus y, 2y cos 2x minus y plus y power of 2 sin 2x minus y. Question 11. So question 11 is about line integer. So firstly, we compute the line integral of xyz equals to xyz along a 3D curve. So x is equal to cos t, yt is equal to sin t, and zt is equal to 3t. And then we can get the magnitude of rt, and we find the equation here, and we can get the xy equals to minus 3 pi 10. So this is the final answer. Proceed to MATLAB question 11. So I use SYMST to define the curve and xyz. So we define the function and the curves, then use the int to evaluate the integral from t equals to 0 and use t equals to 4 pi. So followed by the simplify and evaluate to get the final result. So I try to run, and we can get the common window is final answer is minus 3 times pi times 10 power of 1 over 2. So we can get the value of the line integral here. Question 12. So this is a manual calculation about question 12. So about question 12 is about work done by a force. So we calculate the work done force. So this is a formula for work, and over the interval is x equals to 3 and x equals to 7. So we can get the final answer here, 113.1918 joules of MATLAB. So we use SYMXX to define x, and then we define the force function to use int to integrate within the given limit, and then we compute the work done using symbolic integration. So and after that we convert symbolic result to decimal and display the result. So and then you can get the output result is work done is 113.1918 joules. That I made is question 13. So this is a manual calculation of question 13. It's about surface integral over a triangle. So we evaluate a surface integral of xy equals to 6 xy to the power of 2 over a triangular region where this d is where x greater than 0 and 1 greater than x. And then we can get the region R triangle, and we can get this final answer. Sig sy ds equals to 3 over 4. To question 13 MATLAB. So we use a sqrt tree to put the value, and then this is function of integrate. So we put x minimum and x maximum for integration, and then we use a nested loop 2 times, and then we can get the results. So integral value of the surface is 0.433837. We can get in the MATLAB.
Hi, my name is Sonash Prasad Analaki Magendaran. I'm the fourth member of this group. So I'm going to be explaining about the question 15 and 16, which is a pretty similar question, which is about to determine if the following vector field is conservative or not. So let's look at the manual calculation for the question 15 first. So this is the manual calculation for the question 15. So to the easiest way to check if the vector field is conservative or not is to calculate its curl. So here's the formula for the curl, nabla derived with the vector field. So I have identified each of the value into the I under component I, j, and k. So for the component I, use the del or derivative r per derivative y minus subtract with the derivative q by divide by derivative z, which is equals to we get the value 0. So it's the same for the component k, which is we get the 0. However, for the component z, we get the value 3x squared. So since we get an equal value other than the 0, this automatically defines into the vector field being not conservative or conversative. So here I've used the MATLAB to create a coding to determine if the vector field is conservative or not. So I've used pretty much I've divided into equal parts to compute the curl of the vector field, and then to display the original vector field and its curl. So finally I have added the coding for to show if it's conservative or not, with a line like the vector field is conservative because its curl is the zero vector, or the vector field is not conservative because its curl is not zero. So here's the result we got. So it shows the given vector field is the 6x 2y minus y squared 6z minus x squared. The curl of f, we get 0, and then the for the j component we got the 3x squared, and then the k we got 0. So as we know, the conclusion it shows the vector field is not conservative because its curl is not 0. That's all. There will be a software video upcoming next. So now to the question 16, which is pretty similar to the question 15 before. So it also asks to determine if the following vector field is conservative or not. We will look at the manual calculation first. So this is the manual calculation for question 16, which is pretty similar to the question 15, but I have used a little bit of different approach this time. So this time the condition is to check if the derivative of f1 or derivative y should be equals to derivative f2 per derivative x. So the both of these values should be same. So pretty similar to the next one, derivative f1 per derivative z, which is equals to derivative f3 per derivative x. And then for the third one, derivative f2 per derivative z, which is equals to derivative f3 per derivative y. So both three of these should be the values should be equal. So when these conditions are met, the uh, vector field is definitely conservative. So here's the software solution for the question 16. which I have also used the program MATLAB. So here I have differentiated the parted. So to define the symbolic variables into the x, y, and z, and then I made it to define the vector field into p, q, and r. Previously it was f1, f2, and f3 in the manual calculation, but I used a different approach this time, pqr, to make it easy for you to see, and then I have given the formula for it to compute the curl of the vector field, and then display the original vector field and its curl. And then lastly, as before, I have uh, key in the coding for the to check if the curl is the zero vector to determine if f is conservative or not, like before, to give out the statement after the calculation. So this is the result. The basic one, the given vector field, it shows, and then the curl of f, which is, you can see there's the tree. We get all the values are zero. So this definitely means the vector field is conservative because its curl is in the zero vector. That's all from me. Thank you. There will be a software video up next.